What we have here is essentially the data from the previous example, example 10, but expressed in a Venn diagram instead of a two-way table. What is the probability that a randomly chosen student studies physics? So, physics students will all be in this ring on the diagram. We can see that there are in total 28 students. Now the total students in the diagram are 13, add 15, add 12, add 20, which is 60. Probably should have done that first, but that means that this is 28 out of 60, which of course we could simplify. What's the probability that a randomly chosen student studies physics but not English? Physics but not English are these people. They're in the physics circle but not in the English circle. And therefore the probability that they do physics but not English, that's going to be 13 out of 60. We could actually in there write that as physics intersection not English, meaning physics and not English. What's the probability that a randomly chosen student studies neither physics nor English? Well, that's going to be those 20 people just there. Now, if we carry on and try to use notation like this, those people are not physics and not English. So that's 20 out of 60. What is the probability that a randomly chosen student studies physics or English? Physics or English means everybody who is in this region just here. These are the people who do both. And normally in mathematics, when you see an or, it means the do both case as well. Now there's a notation for that as well. We've got physics, and that's one of these. And that means or. There's no reason why at this stage of your maths you can't write the word or in there. And so in total in there we have 40 people, so that's 40 out of 60. And note that this one was the complement of this one. They add up to 1. What's the probability a randomly chosen student studies physics or English, but not both? So see how when it's an or and we don't want the both situation, we specifically exclude it. That's going to be these people and these people, 25 of them in total. So we have the probability, and I'm just going to write this one out rather than try to use some sort of notation for it. Physics or English, but not both. So that was 25 people in total. So it was the 13 there and the 12 over there. Now finally, what is the probability that a randomly chosen physics student studies English? Now, we know therefore that the student does physics. So we're only looking at the people in here. And there are 28 of those people, and therefore 28 is going to be the denominator for our probability. To study English as well needs to be one of these people. So the probability of English, given that they do physics, there is a notation for that. I'll mention that in a second. So that was going to be those 15 people out of the 28. And as a notation, and you'll learn this in subsequent years, Given is a line like that. So that would mean that they do English, given that they do physics.